All right, ladies and gentlemen, we are ready to get started with Unit 9.4. We have probability and odds. So that's our goals for today. We're going to find the probability of an event and determine the odds of success or failure. So the first thing is we're going to look at the event and in one or more of the favorable outcomes that can happen from a random phenomenon. They are usually noted with a capital letter. So we have T is like flipping a coin and getting tails. F is rolling a fair dice and getting a 5, and Q is picking a card at random and getting a queen. So that's kind of the notation that we might see for an event. I'd be okay if you write like P of, if you wrote queen on the inside, that's fine. That's just a little shorthand that they use. So again, probability, you guys have seen this before. It's just taking the number of ways an event can occur and divided by the total possible outcomes. So as you're going through, there are a lot of questions about cards. I've given you, again, the set of cards here. We should know there's 52 cards in a deck. There's 4 suits. We got, again, half of them are black, half are red, so 26 and 26. We should know our suits. Diamonds, hearts are red, spades and clubs are black. And again, 13 cards in each suit. All right. So as we take a look, example number 1A, it says, what's the probability of selecting an ace from a standard deck of cards? So if I'm doing a probability of an ace, if you want to write ace or just do an A, that's fine, either way. All we got to do is count how many total aces that we have, and as you see, we have 4 aces. And we're going to divide by how many total cards there are in our deck, and we should know there's 52 cards in a deck. So we take 4 divided by 52. You can throw that in your calculator. And again, see what my math lab's willing to take. If I take 4 divided by 52, you guys know math frac. You can convert that to 1/13. All right, so again, there's 13 cards in each suit. You have 1 out of 13 chances. Okay, if my math lab wants a decimal, we would have, again, 0.0769. So 0.077. If they want the percentage, move that decimal place over 1, 2 to 7.7%. Okay. Again, see what my math lab, sometimes they want different things. So for a quiz or test, I'd be okay with any of those. For question B, it says, what's the probability of selecting an ace or a king? So what's the probability of an A or a K for shorthand? That's just taking how many aces we have over 52 cards, and then the number of kings that we have. That's 4 out of 52. So if I look, what's the probability of getting this guy or this guy, ace or king, we would add those numbers together. That would give me a total of 8 cards for my success out of 52. And then go ahead and reduce that. We would get, again, 2/13. Okay. So again, 8 divided by 52, math frac, is that 2/13. If you want that decimal, it's just double that percentage. Okay, so 2/13 would be okay with me. Again, if my math lab wants a decimal, that would be 0.154. That 8 rounds the 3 up. Or if a percentage, 15.4%. And see what my math lab's willing to take. Either one of those works for me. All right. So big idea, anytime it's an or, we are always looking to add those up. So from time to time, you guys might run into a table and they might give you some good information and different probabilities that they're going to ask you. It says here, find the probability expressed as a decimal rounded to the nearest hundredth. So 10 hundredths, that's 2 decimal places, that a randomly selected American living alone is. So here we go. We got male and female, and we have the totals. We have their ages listed, and then the totals here. All right. So the first one is we're looking to see what's the probability that a man or a male is living by himself. So go ahead, find the males. Here's the total amount of men from ages 15 to 75 or higher, and it would have 12.5. So we take the total males and then divide by the total. And the total for men and females is 29.3. So I would take that 12.5 and then divide by 29.3 in my calculator. So 12.5 divided by 29.3, and we should get 0.426. Okay, 0.4266. Asks us to round to the nearest hundredth, so tenths hundredths, that'd be 0.426. That's 6 rounds up, so my answer would be about 0.43 for my answer. The last question here is asking you a woman, what's the probability that a woman in the 15 to 24 age gap is living alone? So as I take a look, I look for female and I look for 15 to 24, that's right there. So again, I take the total for a woman from 15 to 24 and I divide by the total. So I take that 0.8 that we have right there and divide by 29.3. So in my calculator, I got 0.8 divided by 29.3, and that's going to give me my percentage as a decimal. So about 2.7%, or as a decimal rounded to the nearest hundredths, that's 0.027. The 7 rounds up to 0.03. Final answer. So you might see a couple of those on my math lab. Just want to make sure we touch base on that. All right. So the next experiment we're going to be dealing with and looking at that probability is you're going to have a fair die. So just one single die and you're going to roll it twice. All right, and all the different possibilities that you're going to have. So if you roll the first dice and the second dice, you could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, ... Or the first one could be a 2, and then a 1, and a 2, and a 2, and a 2, and a 3, and a ... So for the first dice, we have 6 choices. For the second choice, we have 6 choices for a 6-sided die. If I multiply them together, multiplication principle from Unit 9.1, if I add up all these boxes, there are 36 possibilities. Okay, so I always need to figure out how big is our sample set so that we can do our total on the bottom. So as I take a look, example 3A says a single die is rolled twice. Find the probability of rolling 2 numbers whose sum is 5. So again, I'm going to find the probability of the sum being 5. Now you can just go through and count those out just so it's notes and you guys are following along what I'm doing. I'm going to go and look for a sum of 5. I could roll a 1 and a 4 or a 4 and a 1. I could roll a 2 and a 3, or I could roll a 3 and a 2. So I'd add up all those and divide by the total possibilities, which is 36. Okay, so again, if I look, these are up here 4 times out of 36 possibilities. And go ahead and reduce that, that ends up to be 1/9. Okay, if you throw that in the calculator, 1/9 is 0.111 repeating, or 11.1%. Again, see what my math lab's willing to take. I'm okay with any 3 of those. Okay. Now if I take that same question, example 3B, but I change it a little bit, it says a single die is rolled twice. Find the probability whose sum is 11 or more. So that means that my sum's going to be 11, or it could be 12. I can't go any higher than 12 because that's all we got. So I have the probability of a sum of 11 or more. So look at all the different possibilities you have up there. Probability of sum of 11, I could roll a 5 and a 6, or I could roll a 6 and a 5. That would give me 11. I can't roll anything with a 4 because 4 plus 5 is 9, 4 plus 6 is 10. It just doesn't get up there. And then the only other option is for more would be 6, 6. I could roll a 6 and a 6. That's divided by all my possibilities. Well, that ends up to be there's 3 possibilities out of 36. Go ahead and reduce that, and I end up with 1/12. Okay, if you want the decimal, 1 divided by 12 in my calculator gives me 0.083 repeating. And if you move that decimal place over, that's just 8.3%. Again, see what my math lab's willing to take. Sometimes they change it up. So any 3 of those on a quiz or test I would accept. All right. So as we take a look, if you need to, you can always use a highlighter. If you're needing to find the sum of 11 or more, you could go through, well, here's 6, 5, here's 5, 6, 6, 6. And that's where we get in those 3. There's no other combination up there that will give me 11. Okay? We'll use that idea now as we do something called the complement. So the complement of an event, the best way I can give you is when I am trying to decide if we have golf practice or not, because I'm the golf coach here at Career Grove, I look to see what's the percentage of rain. So if I have rain at 30% chance of rain, the complement to that is what's the chance that it's not going to rain. So a complement is what's the opportunity, what's the percentage, what's the probability that an event's not going to occur. So that's called the complement. Well, what's the percent of no rain? So we can get out there and golf. Well, an easy thing to do is just use your little formula here. The probability of no rain is just taking 1 minus the probability of rain. So the probability of no rain, I would just take 1 minus 30% or 0.30, and I would get 0.70 or 70% chance that it's going to be nice and pretty out. That's the complement. Okay, so if you know a percentage of 1, then you know the percentage of the other by just subtracting from 1 minus that answer. Okay. If you have a percentage, you subtract from 100. Okay, so if I look at example 3C now, it says what's the probability that the sum is less than 11? So that means the opposite of what we just did. So the probability of less than 11, so that means not 11 or 12, not 11 or greater than, then I got to take 1 minus the probability that the sum is 11 or more. And in our last example, we had that probability was 0.0833. Well, that gives me 0.916 in the calculator. If I take 1 minus that previous answer, there we go. That's where I'm getting that number. Again, if you want the percentage, that's 91.7%, because this is 0.66. Again, either one of those I'd accept, either 0.917. Go ahead and round up. Depends on what their percentage, what decimal place they want. Either one. If they want the fraction, we look at the complement. I want the probability of that. Look at what we just did. Of the 36, 3 of them have a sum of 11 and more. That means all these guys have a sum of 10 or less. That would be the complement. So hopefully that makes sense. Again, we add those up. That's 33 out of 36. 33 out of 36 reduces by 3 to get 11/12. Okay, on the other side, we had 1/12 as the answer. Okay. So that's the big idea of complement. Once you know one percentage, you can find the complement. Okay, it's like yin and yang, right? It's like mashed potatoes and gravy. Those complement each other very well. All right. Last but not least for today is looking at odds. Okay, so you might see this from time to time as looking at odds. Odds is very similar to probability. And as we take a look, it says odds are another way of expressing the chances or likelihood of something happening. Odds can sometimes be split as odds in favor of and odds against. But we'll express odds as the ratio of successes to failures. All right, so successes to failures is how we're going to set it up. So odds is the number of ways an event can occur versus the number of ways an event cannot occur. Okay, the number of successes over the number of fails. If you want to write it as a colon, and we can show you that as well. Okay, so here we go. We're going to roll a single die, a single six-sided die. Find the probability that you're going to roll a 2. Well, if I roll a 2, that's only going to happen. So a probability of rolling a 2, that's only going to happen 1 time out of 6. Well, that means for my odds, successes over failures, so my odds would be 1 that I succeed in rolling a 2, and then that means there's 5 other chances that I'm not rolling a 2. Okay, I could have rolled a 1, a 3, a 4, a 5, or a 6. Okay. If you prefer to write it like this, and this is what I usually do, is I'll write it like with a colon. It's a 1 to 5 odds. Okay. Well, vice versa, what's the odds in favor of not rolling a 2? Well, there's 5 possibilities of not rolling a 2 versus only 1 possibility of rolling a 2. So the successes of not rolling a 2 would be 5 versus being unsuccessful in rolling a 2. Okay. So the last one is, what's the odds? I'll make this one up. What's the odds in favor of the Bears over the Packers on Saturday night here? That's 1 million to negative 89. It's going to happen. Hopefully that aged well. All right, the Bears. Go Bears. All right, so on the back I've got some extra student examples. I ask you to state the odds given the probability. So again, if I have a probability of successful of 5 out of 8 times, that means I'm going to be successful 5 times, and then if I look at my unsuccesses, that'd be 3, because 5 plus 3 is 8. And if it says state the probability given the odds of 6 to 5, I'm successful 6 times, unsuccessful 5 times. If I add those 2 up, that will give me my total possibilities. That would be 6 out of 11. So here, example 7, it says the odds are 6 to 1 that the visiting team will win on Friday. What's the probability that the home team will win? Well, looking at the odds, the probability of the visiting team wins, the visiting team is going to win 6 and lose 1, so there's a 7 possibility. 6 out of 7. 6, 7. What's the probability that the home team wins, though? So if that was your answer, ooh, that's wrong. I want the home team to win. Well, the home team winning, that probability would be the complement. What's left over? That'd be 1/7. That's what we're looking for. Okay, so the visiting team wins 6 out of 7 times. That means they're going to lose 1 out of 7. That means the home team's going to win. All right, finishing up with example 8 here. It says find the probability and odds of following events in 2 distinguishable dice are tossed. It says here the dice total 7. So again, I'm rolling 2 dice. Like they're distinguishable, one's red, one's green. So we're looking back at that same setup that we had over here. There's 36 possibilities. So if I want the probability that the dice total 7, I have a sum of 7. You've got to look at all the different ways you can get 7. So again, we're looking for the sum of 7. We could get a 1 and a 6 and a 1. We can get a 2 and a 5 and a 2. We can get a 4 and a 3, or a 3 and a 4. And that's all the different possibilities out of 36. So if I count all those up, or if you're looking at your table here, look at those boxes. That gives me 1, 2, 3, 4, 5, 6 out of 36. Reduced is 1/6. Again, see what they're asking for. Okay. So that's our probability. If they ask for the odds, I'm going to get a sum of 7 one time, and that means there's 5 that I wouldn't get a sum of 7. The odds are 1 to 5. For example, 8b says at least a 2 appears. So probability that I see a 2. So we'll kind of go through and look at all the possibilities. I could roll a 1 and a 2, or I could get a 2 and a 1. I could get a 2 and a 2, or I could get a 2 and a 3 and a 2. I could get a 2 and a 4, or I could get a 4 and a 2. I could get a 2 and a 5, or a 5 and a 2. And the last ones I got 2 and a 6, or a 6 and a 2. Again, you have this table over here. You can kind of look at all those for all those 2s. All right. And if I count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36 would be my answer. Okay. So my odds for this one, there's 11 successes, and if I subtract those 2, that means what? There's 25 failures. So those would be my odds. All right, example 9 and 10, we're going to wait for the next day. So we'll maybe use this as a warm-up for the next day. So ladies and gentlemen, that is it for today. You guys have a great day, and we will talk to you tomorrow.